Hi guys, last week we reviewed the trig ratios that you learned when you were in geometry, so we're going to take that a little bit further for the rest of the school year. We'll be looking at trig functions. So I'm going to introduce you to some new trig functions today, but let's just talk about the ones you worked with last week. So first of all, we know that we're dealing with right triangles always, and the three sides of a right triangle consist of the hypotenuse and then two legs. The two legs are the horizontal and vertical sides that form this right angle right here. Now, when we're talking about trig ratios, we always refer to a particular acute angle. So we already know that we have a right triangle, so one of the three angles has to be the right triangle. The other two angles are what we call acute angles because their measurements are less than 90. So we focus on just one of those two. So in this case, we're going to focus on this acute angle right here, and we call it theta. It's a Greek letter. And so we're going to use this Greek letter theta to represent our unknown angle measure. And we know that if this is the angle I'm interested in, then I'm going to travel across this right triangle to the side that doesn't actually form this angle. There's a side over here that doesn't help form the angle theta, and we call that the opposite side of our of theta. And then there's a side that does help form theta, but it's not the hypotenuse. It's the other leg, right? But it does help form theta. So it's part of theta. We say it's adjacent to theta. The word adjacent means that it's next to theta. So this side is adjacent to theta. Now, you know and are comfortable with the sine, the cosine, and the tangent of an angle. They're ratios that compare two of the three sides of the right triangle to each other. So the sine specifically compares the opposite side's length to the hypotenuse. So the opposite side's length to the hypotenuse. And sometimes you see it O over H. And then the cosine compares this adjacent side's length to the hypotenuse. So we say adjacent over the hypotenuse. Sometimes you'll see it written A over H. And then the tangent compares the two legs, and specifically it always starts with the opposite side's length compared to the adjacent's. Opposite comes first compared to the length of the adjacent side. So opposite over adjacent. And then you guys remember from geometry and from your videos last week that we remember how which two sides go with each of our trig ratios and in what order by saying the word so, ka, toa. And for me, I always write it like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So now we have new trig ratios, and there are only 6, right? So there won't be any more after these 3. So we already know 3. We worked with those in geometry. We reviewed them last week. So the other 3 are what we call the reciprocal ratios. Reciprocal. And if you'll remember, a reciprocal is simply when we take the numerator and the denominator and we interchange them. So this is and I'm going to write these words here. This is called the cosecant, is how we say it, right? It's the cosecant, and the cosecant is the reciprocal of sine, and that's going to be important to remember. And so it's usually written right next to the sine ratio. So we're going to write this as the hypotenuse compared to the opposite. So notice that this cosecant is the reciprocal of the sine. And then this is the abbreviation for, we're going to say secant, and the secant is the reciprocal of the cosine. So we're going to write and define the secant as the hypotenuse compared to the adjacent. Now the hypotenuse is in the numerator instead of the denominator. And then we say cotangent, and this is how it's abbreviated, is COT, and it's the reciprocal of the tangent. So this is defined as the adjacent side's length compared to the opposite side's length. So let's look at some examples. So I'm gonna slide this up. So we have some right triangles down here. Let's look at this first one. And we know that the three sides of a right triangle have to satisfy the Pythagorean theorem, right? So 20 squared plus 21 squared would be exactly the same value as if 29 was squared on the other side. So now we're going to name all of our 6 trig ratios for this particular triangle, and not just this particular triangle, but this triangle whose angle measure we're interested in is this particular angle here, theta. And the reason that it matters that I'm looking at this angle is because for this angle, 21 is the opposite side, and 20 is the leg that forms theta, so it's my adjacent side. And then the side that's opposite the right angle, always the longest side, is called the hypotenuse. So it matters which of the two acute angles I'm interested in, because if I had looked at this one down here, the opposite and adjacent would be in a different, they would be interchanged. So, okay, so now we come down here. So for this particular angle, its opposite side compared to its hypotenuse would be 21 to 29. Okay, and then for the cosine, we look at the adjacent side compared to the hypotenuse, and so that would be 20 compared to 29. And then for tangent, we're looking at just the legs, and that's these two numbers, always opposite to adjacent for tangent, so 21 to 20. Okay, and all we have to do for the reciprocals is to interchange the numerator and the denominator. So because cosecant's the reciprocal of sine, I'm going to rewrite this ratio as 29 to 21. That's the cosecant, the reciprocal of sine. Secant's the reciprocal of cosine. I'm going to rewrite this ratio as 29 to 20. Cotangent's the reciprocal of tangent. We'll rewrite this ratio as 20 to 21. Okay? All right, so if I look at this example here, notice that they only gave me 2 of the 3 sides of my right triangle. That's okay, because for right triangles and only right triangles, I only need 2 sides, and then I can always figure out the third using the Pythagorean theorem. So if I took 5 squared plus 12 squared, I'd get 169. The square root of that is 13. So we're going to put 13 over here. Okay, and again, we have to identify which of the 2 acute angles we're interested in, and it's this one down here that we've labeled as theta. So that's going to make 5 our opposite, 13 is our adjacent, 12 is our adjacent, and 13 is opposite the right angle. Always the longest side is the hypotenuse. Okay, so again, we remember SOHCAHTOA, so sine is opposite over hypotenuse, so opposite is 5 over the hypotenuse of 13. Cosine is adjacent over the hypotenuse. And then the tangent is opposite over the adjacent, opposite 5 over the adjacent of 12. Okay, cosecant is the reciprocal of 5/13, so now we're going to write 13/5. Secant is the reciprocal of cosine, so we rewrite this one 13/12. And cotangent is the reciprocal of tangent. We rewrite this one as 12/5. Those are the 6 trig ratios for this angle theta in this particular right triangle. Okay, so when I come over to this right triangle, this time they gave me one of the legs is 35, the hypotenuse is 37. Again, I'm going to need to apply the Pythagorean theorem to find my third side. So 37 squared minus 35 squared is going to give me 144, and that square root is going to be 12. Okay, before I can talk about my trig ratios of theta, I need to look at theta over here. This is my angle I'm interested in. I go all the way across and make this my opposite side of theta. The 35 helps form theta, but it's a leg, so it's my adjacent side. And then the third side here is opposite the right angle. It's always the longest side that is the hypotenuse. Okay, and then I think you guys can do these on your own. So I'll slide this up, okay, and talk about some of the ways that if they gave me just one of my trig ratios, I can find the other 5 for that particular angle. So let's talk about that. So I'm going to first just draw a right triangle just to get a nice visual. Okay, this is going to be my right angle here. And I know that the tangent ratio compares the opposite side over the adjacent side of the right triangle. That's the TOA in SOHCAHTOA. TOA, tangent is opposite over adjacent. So I can put theta anywhere I like in here, right? So let's put it here. I could do it here or here, doesn't matter. Okay, so this, if I call this theta, its opposite side is here. I know it's got a length of 15. Okay, and then the adjacent side is the leg that helps form theta, and I know it's got a length of 8. So they've given me 2 of the 3 sides of my right triangle, and I can easily use the Pythagorean theorem, and I'm going to add the 8 squared plus the 15 squared will be 289, and the square root of 289 is 17. I'm going to write it in a different color just to let you know we had to use the Pythagorean theorem to find that. So we've already labeled 15 as our opposite, 8 as our adjacent, 17 we had to go out and find is our hypotenuse. So now I'm going to write my other 6 ratios. So I'm sorry, my other 5. So the sine of theta I can come over here and see is the opposite over the hypotenuse is 15/17. Okay, now its reciprocal is the cosecant of theta, so I'll write that as 17/15. Okay, cosine is the adjacent length over the hypotenuse. It's 8/17. Its reciprocal is called the it's called the secant. So the cosine's reciprocal is the secant of theta. I'll rewrite this as 17/8. Now they already gave me the tangent. This was given, so I'll write it in a different color for you. We were given this originally, and its reciprocal is the cotangent, and so that'll be 8/15. Cool.